Hello all, welcome back to our Lakshmi's physics class. Let's see the solution for this question. A block of mass 8 kg is released from the top of an inclined smooth surface as shown in the figure. If spring constant of a spring is 200 Newton per meter and block comes to rest after compressing spring by 1 meter, then find the distance travelled by block before it comes to rest. Okay, so let us list out the given values. So here given mass which is 8 kg and spring constant is given, that is K, which is equal to 200 Newton per meter, and block comes to rest after compressing, so its final velocity will becomes 0. So hence kinetic energy, final kinetic energy will becomes 0, and initially block is at rest, so initial velocity is also 0, so initial kinetic energy is also 0. And after that compress a spring by 1 meter, so x equal to 1 meter, this is the compression in the spring. Okay, so now let us redraw the diagram. So here is the block now, 8 kg block. So if it is compressed, so this is, if it is compressed this much, so this is the compression in spring, that is x equal to 1 meter. So now we need to find the distance travelled by the block up to here. Let's say this is d, this is how much. Now finally the position of the spring is here, so this is the height from here to here, this is the height. So we need to find the distance travelled by the block before it comes to rest. So now this is given as 30 degree, hence this is also 30 degree. So now let us see from the diagram, sin 30 degree equal to, so that is h upon d. So from this sin 30 degree value is 1 by 2, which is equal to h by d. So plus d equal to 2h and h is equal to d by 2. Okay, let it be like that. Now from the law of conservation of mechanical energy, from the law of conservation of mechanical energy, we know that total energy is constant. That means sum of the kinetic energy and potential energy is constant. So from this we can write initial kinetic energy and initial potential energy is constant, and final kinetic energy plus final potential energy is constant. From these two equations we can write that initial kinetic energy plus initial potential energy must be equal to final kinetic energy plus final potential energy. Okay, now so let us substitute the values. Initially block is at rest, so initial energy is 0, so initial kinetic energy is 0, so we can substitute here 0. And potential energy has, initial potential energy is two types here. Since the block is at certain height, so it has gravitational potential energy, that is mgh, and also spring potential energy. Here the block is not doing any work, hence we can say that the gravitational potential energy due to the spring is 0. So here only one potential energy, that is mgh plus 0. Okay, and which is equal to, finally block will comes to rest, so final kinetic energy also 0, and finally here u final is also two types, that is gravitational potential energy. So in this case gravitational potential energy is 0, and now here a spring potential energy is 1 by 2 k x square. Now substitute that here, 1 by 2 k x square. So finally we got it, mgh is equal to half kx square. Substitute the given values, that is 8 kg, and acceleration due to gravity is 10, and height, so from this equation h is equal to d by 2, which is equal to 1 by 2 into k is given 200 and compression is 1 meter. So from this 2 1s and 5 2s, and this will get cancelled here 100 times. So 8 5s, 40 d equal to 100 and d equal to 100 upon 40. So this will get cancelled. This is 2.5 times. Hence distance travelled by the spring before it comes to rest is 2.5 meter. I hope this is useful to you. Please like the video, share with your friends, and don't forget to subscribe the channel. Thank you for watching this video.